I'd like for us to revisit a problem that we just did in the previous video, where we were solving this particular exponential function by using logarithms. And in that last video, let me just pull up our work from that last video. We solved this exponential function by rewriting this exponential expression as a logarithmic expression. And it turned out that when we did that, we had a log that was in base 1.01107, which was not in base 10. So we had to use the change of base formula to rewrite this in base 10 so that we can put it into our calculator and evaluate that to solve for t. And we also mentioned in this video, or I mentioned in this video, that there are several other ways that we could have solved the same exponential function. So that's what I would like to take a look at in this video, is another method of solving the same problem. So here, I would still like to take a look at how to solve for t. So let's solve for t, still using logarithms. So using logarithms. But instead of applying the change of base formula, I want us to focus on another important property of logarithms. And the property that I want us to focus on is the power law. So let me just write down real quickly to remind us of the power law of logarithms. Oops. Logarithms. We just use a different color here to brighten it up a little bit. So if we recall, the power law tells us that when we have the log base b of some number raised to a power, let's call that power c, we can rewrite this as c times the log base b of a. So these two expressions are equivalent to each other. Okay, so let's keep that in mind. Let me just box this, because we're going to come back to this and apply it to help us solve for t. So going back to this problem, if we remember from what we did the last time, we want to isolate t, and we want to first get the exponential term, the 1.01107 to the t by itself on the left-hand side. So to do this, we're going to divide both sides by 53. That cancels out, leaving us with 1.01107 to the t is equal to this fraction 56/53. Okay, so again, when we want to solve for an unknown or a variable in an equation, we always use inverse operations to try to isolate that variable. So that's what we did in this first step here. We did the inverse operation of multiplying by 53, so we divided both sides by 53. And then now we've got this exponent, this power t, and we want to know, how do we undo it? What is its inverse function? Okay, so if we think of a simpler example, let's go back to that same example that we used the last time, where we had 2 raised to some unknown power is equal to 8. Well, if I want to solve for x, I can solve for x by rewriting this expression as a logarithmic expression. So I can rewrite this as log base 2 of 8, and that's what's going to give me x. Okay, so if I want to undo this exponent, its inverse is the log. But instead of taking log base 2, if I can get t by itself by taking the log of base 10, then that would work out really nicely, because I can actually put that into my calculator, because my calculator has log in base 10. So what I'm going to do is I'm going to take the log base 10, and even though I wrote that there, I don't really need to write that there. Well, if we just write log, then we know that that means log base 10. Okay, so I'm going to take the log of the left-hand side here, but since this is an equation, remember that whatever we do to one side of the equation, we have to make sure that we also do to the other side of the equation. So I'm also going to take the log of 56/53rds. Now, what's nice about this expression that we have on the left-hand side of the equal sign here is that we've got the log, think of this as base 10, of this number raised to the t. And we can rewrite this by applying the power law. We can rewrite this as the power times the log base b of a. So I can rewrite this expression by applying the power law. Right, we can rewrite this as t times the log, and again base 10, of 1.01107, and that's still equal to what we have on the right hand side here. We'll just bring that down, the log of 56 divided by 53. Okay, all right, let's continue isolating t. So right now t is attached to this whole thing by multiplication. So to get rid of that, or to undo that, we're going to divide everything by the log of 1.01107. And again, since this is an equation, remember whatever we do to one side, we have to make sure we also do to the other side. So this cancels out on the left, leaving us with t. So we've just isolated t, which is exactly what we want. And on the right-hand side, I'm just going to bring this down again. I'm going to rewrite this as log. And remember, this is base 10 of 56 divided by 53 divided by the log, base 10, of 1.01107 is equal to t. So hopefully, I hope that you'll notice that this expression looks really familiar. And that's because back in the last example, when we solved the same exact equation, remember that we used the change of base formula, and nowhere in here did we actually apply the power law. But notice that we ended up with the same expression down at the end here, and that's what we put into the calculator to get 5. So in this problem, here we did apply the power law, and we ended up with the same expression. So if we put this into our calculator, we should also get the same solution, that t is equal to 5. So isn't that beautiful? I think that's great. So if you're interested in finding one more method of solving this problem, then look forward to another video where we'll solve this same exponential function, but we'll do it graphically.